We were talking about classifications of matter. So let's review this table as kind of a summary here. We can group matter into two categories: pure substances and mixtures. The key element of a pure substance is that all the particles in the pure substance are the same as each other. In a mixture, you're going to have two or more different kinds of particles. So the word mixture in this context means much the same as it does in everyday life, right? It's two or more things together. So pure substances are divided into elements and compounds. Elements are composed of atoms, and you can't break it down into anything simpler. It's already as simple as it can be. The compounds, though, contain molecules. They contain groups of atoms. You can separate those groups of atoms, the molecules, into individual elements. So the example here, these are sugar cubes. And this is what a molecule of sugar looks like. It's got oxygen atoms and carbon atoms and hydrogen atoms. And so you can take a molecule of sugar and break it into three different elements. That makes it a compound. Here, I think this is, those look like copper rods, perhaps. If we look at the particles in the copper, there's only one kind of particle. If you take this apart, you've just got smaller pieces of copper. Okay? Over here under mixtures, there's two kinds of mixtures. Homogeneous, meaning it mixes thoroughly. It's the same throughout. The prefix homo means the same. Heterogeneous, hetero means different. And so this is different. Here we have an example of oil and water. The oil and the water do not mix together, right? They're in the same container, but they're going to separate into layers. And so on the top, we see these oil molecules, and in the bottom, we see water molecules. Other examples of heterogeneous mixtures might be chicken noodle soup, or macaroni and cheese, or dirt and sand. You can see that there's a difference. There's different parts in the substance. It's not all the same. Here we have an example of a homogeneous mixture. Here are sugar molecules. And I'm not sure exactly what that is. Could be caffeine. Looks kind of small for caffeine. I don't know what that is. And water molecules. These are mixtures, and we see that there are different kinds of particles in them. But in this mixture, it's the same all the way throughout. That's tea with sugar in it. And the top and the bottom are the same. What happens when you let chocolate milk stand for a while? The chocolate goes to the bottom, right? Cocoa does that too. Is that a heterogeneous or a homogeneous mixture? Heterogeneous, because it separates out. A homogeneous mixture will not do that. If you have a hot cup of tea with sugar in it, and you let it sit for a while, it's going to get cold, the temperature will change, but nothing's going to settle out of it. It's homogeneous and it stays mixed. Any questions about these groupings of matter? So let's look at an example. Classify each type of matter as a pure substance or a mixture, and then further categorize it. If it's a pure substance, is it an element or a compound? If it's a mixture, is it homogeneous or heterogeneous? Some of these could be a little bit challenging. Questions I ask on an exam will be more straightforward, like this one with minestrone soup. I would not assume that everyone knows what minestrone soup is, okay? But in class it works out okay. So the mercury in a mercury thermometer, pure substance or mixture? It's a pure substance. That does require a little bit of background knowledge. And then, is that an element or a compound? That's an element. One of the clues is that mercury is on the periodic table. So this is a pure substance, and it's an element. How about exhaled air, the air that you breathe out? Pure substance or mixture? Mixture. And is that homogeneous or heterogeneous? Homogeneous, hopefully. Unless you're blowing chunks, right? But that's not really exhaling air, that's throwing up, which we don't want to talk about. But the air that comes out of your mouth or your nose when you breathe out is thoroughly mixed, just like the air in this room. It's uniform. Minestrone soup, compound or mixture? Mixture. Homogeneous or heterogeneous? Heterogeneous. In case you don't know, minestrone soup has like green beans and twirly noodles and kidney beans and little chunks of carrot and all different. It's a chunky soup. And then it's got some beef broth in it. So you can see that there's different pieces in it. How about sugar? Sugar is a pure substance. Is it an element or a compound? It's a compound. And that, again, I would not expect to be obvious to everyone. Any questions about that?